All right, cool. So we're going to talk about recursion today. So we know that recursion is when we define something in terms of itself, right? So define in terms of itself. So essentially, in computer science, what we're going to use this for is to break down a bigger problem into smaller problems so that we can solve those smaller problems. So if we wanted to do 6 plus 9 plus 12 plus 3, this is like a pretty big problem. I mean, it's not hard, but there's a lot. We can break it down into simpler additions to make it a lot easier for us. So we can say that this is the same thing as 6 plus the sum of 9 plus 12 plus 3. So essentially breaking this part down into 6 plus this sum. And then we can do this again, where we can go 6 plus 9 plus 12 plus 3. So we have an even smaller part. And we're going to do this one more time, so that we get 6 plus 9 plus 12 plus 3. And so now, we've gotten to the point where we can't break this 3 down any farther, because it's just one number, right? So we're going to call this our base case. So this is when we're not going to define it anymore in terms of itself. It's just it. That's all it can be, right? So this is our base case. And then what we're going to do is we're going to take 3 and we're going to add the number right here, because we can't break this down anymore. So then we get 6 plus 9 plus 15, right? So now 15's right here. And then we're going to add the 9, right? So then you get 6 plus 24. And then the last little bit is just adding the 6 to the 24 and getting 30. So then we were able to take this problem and break it down into smaller parts so that we can make this a lot easier to achieve. So that makes this our recursive case. So essentially, if we're defining this for Python, we're going to have a general recursive form that all of our Python codes are going to look like. And what it looks like is you're going to define your function. So you're going to have your recursive function, and then you're going to have an if statement followed by whatever your base case is. And if that is true, then you're going to do something that isn't recursive. So in our last example, we have 3, and we're just going to return 3 because we're not getting any farther down, right? So just have 3. But if your base case isn't true, then you have an else statement, and it's going to do something recursive. So here you have this, and then you're going to recurse down to this, recurse, base case. And that's all that is. All right, cool. So a good example for recursion in real life we can use is factorial. And so what factorial is say you want to have 3 factorial. This is equal to 3 times 2 times 1. Just all the numbers that come before it and including it, and you just multiply them together. So the way we can do this recursively is by saying that 3 factorial, which is equal to this, is equal to 3 times 2 factorial, right? Because 2 factorial is just all the numbers before it, including 2, and then you multiply by 3. And then we know that 2 can be broken down, so this can be broken down into 2 times 1 factorial, and 1 factorial can be broken down into 1 times 0 factorial. And so 0 factorial is weird, it's a weird case. This is equal to 1, just is. So this is going to be our base case right here, right? Because right when we get down to 0 factorial, it's always equal to 1. And then we can use this to build up from here. So then 0 factorial is 1. So then you do 1 times 1, which returns 1. And then you do 1, this one, times 2, which returns 2. And then you take this 2 and you multiply by the 3, because this is 2 factorial, that's the sum of it. And then this returns 6. So 3 factorial equals 6. So then if we want to code this in Python, I'm going to switch over to the laptop here. So if we're going to use our general recursive form, we're going to define factorial. We have to take an input. And for general recursive form, we have an if statement, right? And we want to have our base case. And so we want to remember that our base case is n equals 0. So when we have 0 factorial, that is always equal to 1. So we're going to return 1. And then, as for the other part of general recursive form, we're going to have our else statement, where we're going to return something that is recursive. So we're going to return n times the factorial of n minus 1. So right here, we are defining factorial up here in terms of itself, a factorial minus 1. So then, if we run this, we're going to go down here, it's going to, we're going to say you want to do factorial of 2, it'll give you 2. You do factorial of 10, you get this big number. And you can keep doing this by defining it in terms of itself.